When we look at the universe through the lens of classical mathematics, we hit a wall. The equations that govern reality do not seem to care which way the clock is ticking. If you map the trajectory of a moving object using Newton's laws of motion, time is simply a variable. The math works perfectly whether that variable is positive or negative. The fundamental equations of motion have no temporal direction. Take orbital mechanics. If a planet is circling a star and the entire system suddenly reverses course, the physics remains completely valid. By calculating those orbits, it is mathematically impossible to deduce whether you are watching events unfold into the future or rewind into the past. Gravity works either way. In 1927, British astrophysicist Arthur Eddington investigated this exact anomaly. He realized that the mathematical rules governing planets and particles lacked any definitive direction. This leaves us with a glaring contradiction. If the basic building blocks of the universe operate symmetrically, without a forward or backward bias, macroscopic reality should theoretically be able to run in reverse. Step away from the chalkboard, however, and that mathematical symmetry collapses. Hold a solid geometric object in the air and let it go. Gravity pulls it downward until it strikes a hard surface. If you watch a video of those ceramic shards leaping off the floor and fusing back into a perfect mug, your brain instantly flags it as an impossible physical event. This is irreversibility. A physical system cannot return to its previous, unbroken state without the expenditure of external energy. The drop causes the shatter. The shatter never causes the drop. At our scale, cause and effect flow exclusively in one direction. An isolated atom might not know the difference between past and future, but a broken mug clearly does. There is a secondary mechanism operating above the level of individual particles, a strict mechanical law that explicitly forbids human-scale reality from moving backward. To locate that mechanism, we have to look past the illusion of a flowing clock and examine the mechanics of probability. The universe does not recognize human concepts like a coffee mug. It only physically tracks a massive collection of atomic coordinates. When we observe an object's temperature, pressure, or geometric shape, we are looking at its macrostate. This is the large-scale, experimentally observable condition of the system. Underneath that summary is a microstate, the specific, instantaneous arrangement of every single constituent particle required to create that macrostate. For atoms to construct a solid, watertight vessel, their coordinates must align with extreme precision. The mathematical probability of those atoms spontaneously organizing into that exact functional structure is incredibly low. This diagram shows the statistical reality. There are only a few exact atomic configurations that result in a usable mug, but there are trillions of random coordinate arrangements that qualify as a useless pile of debris. Objects do not break due to an active, destructive physical force. They shatter simply because there are vastly more ways to be broken than to be whole. In the late 19th century, physics shifted away from pure classical forces, and Austrian physicist Ludwig Boltzmann applied this statistical logic to the problem. Boltzmann sought to resolve the macroscopic irreversibility paradox using pure probability statistics. He achieved this by defining entropy. Entropy is a thermodynamic state variable measuring the exact mathematical number of microstates that can produce a given macrostate. Here is Boltzmann's equation. Entropy, S, equals the Boltzmann constant times the natural logarithm of W. W represents all possible arrangements. An ordered low-entropy state requires exact coordinates. Conversely, a disordered high-entropy state accepts massive arrays of random data, producing the same scattered result. Entropy is not chaos. It is purely a measure of data corruption. Atomic coordinates inevitably drift toward their highest probability distribution. This statistical drift connects directly to classical thermodynamics, a field born out of early industrial mechanical engineering. While analyzing engines, 19th century engineers observed that heat always flows from a hot body to a cold body, inevitably losing usable energy in the process. German physicist Rudolf Clausius recognized that this one-way energy dispersion was a fundamental rule of nature. He formalized this as the Second Law of Thermodynamics. It dictates that the total entropy of an isolated system and the universe itself must inevitably increase. This strict mathematical law prohibits perpetual motion machines. It guarantees that the universe's usable energy is constantly degrading. Every physical action, an engine firing, a star burning, or a heart beating, extracts a permanent entropy tax from the universe. The microscopic mechanism of this entropy tax is heat. Random thermal fluctuations are constantly shuffling the atomic data of the cosmos. This endless shuffling mechanically forces all physical systems to inevitably drift toward their most probable, highest entropy macrostates over time. Maintaining atoms in a low entropy formation requires a constant influx of energy just to fight the overwhelming statistical probability of dispersal. This statistical, irreversible drift of entropy is directly connected to the forward motion of reality. Physicists call it the arrow of time. Time is not an empty stage where events passively occur. It is identical to this unidirectional cascade of increasing entropy. The universe possesses no inherent malice. There is no active force that seeks to destroy structure. Biological aging, data corruption, and the shattering of an object are simply the blind execution of mathematical probability. The macroscopic universe cannot rewind because achieving that specific microscopic alignment in reverse is a statistical impossibility. The physical transition from a low probability ordered state to a high probability disordered state is the only true marker we have of the future. The forward march of time is merely the sensation of the universe physically decaying into its most probable configuration.